Kira, today we try to solve this question from your week 3 activities, which is very good example for your assignment 1, but it's slightly different. So your assignment is about Reynolds number. This one is about different files with data related to different rivers in Waikato region. So the following activities are to be completed after class. So that one, post activities, that's where you can find it, is related to the exercise. The following files contain river levels data for 5 different locations for a period of 1 week. River level 1, so that is the name of the file, kind of like, as you can see, is repeated, but we're changing the number 1, 2, and 3, and 4, and 5. The extension of the file is CSV. I download the files from Moodle, and I can see them here for me, those 5 different files. All right, so when we try to go through anything, so if I've done this before, I'll just clean everything and run it, save the file as river example 24 to make sure I'm not interfering with my previous codes I've done before in the past to go through it. So this type of files, we'll solve it in a different method. So first of all, we'll just minimize this as well. We know what we want to do, and we want to plot the results from step 2, which is the reading and calculating the average, maximum, and minimum river levels for each one, and we need to specify when exceeded the warning level. All right, so number of files we're trying to read is equals 5, as you can see them in the question itself. So 5 files, CSV. Now, because we want to calculate the mean and maximum and minimum, so I could create an empty like matrices for them. So mean water level, and remember to use underscore so you don't get it, and make it 0. So kind of we're booking a space for it with related to the number of files, and we're trying to get that to be as 1 for it. So if I run that one, you can see what exactly I generated. So number of files is 5. Mean water level, I created 1. So the matrix which is representing these values of 0. Now, if I say, if I have more information, for example, let's see if I change that value to 2 and run it so you can see what it's exactly generated for me. But in this case, I'm just reading the maximum or mean or minimum values for that river. So I need just 1 to produce here. I will repeat that one, but with tiny changes, which I'll show you then, just to save my time. So here will be the second one is maximum, and the third one will be minimum, so MIN. And remember, this kind of like what we done is just booked up like a place for them. So you go to the maximum, you go to the mean, you go to the minimum, and all is just 0. So we haven't solved anything yet. It's just we telling I have these files. Now, I need to know the location for these levers. So I will create a location reading for it. So location will be the cell, and that will be the number of files. You see it's picking up for me, and 1 for it. And I'll show you what does mean that for us. So here, if I write my comments, it's declaring all or declaring a cell array which is consists of the 5 rivers. So if I run that for you, you can see the location is generated for me. These one of them 1, 2, 3, 4, 5. And if I have multiple data, multiple files, I could make it that to be 2, and you can see that number will generate for you the second column and third column. All right. So that is the location. Now I need to build up a for statement for loop to read these 5 river files here. So we use the for I file. So I'm reading an I file equals from 1 number. The first file is number 1. I can see it here. Underscore 1 to the number of files. So we're reaching to that file, which is number 5. And that way, I'm just going through it step by step. file name equals. Now we need to tell Matlab what file are we reading. So I will copy that one, F2, and I'll show you how can we use it in a nice way. So that is the file name we're trying to read. Make sure to be following this space very carefully. We use that command number to string ifile, because it's changing with the number of files, and then that would be the extension CSV. So that way, I try to read the files for me. So if I run it now, it will give me an error, but we just give it a try because it's not really end. So if I end it, let's see if it can runs for me. And now I ended it up for you. And you can see now it's the file name river. It's just to tell me it's recognized the files and going through it. But I don't want to end it now because I haven't done much in it. So now, file identifier or file identification, FID, so file identification equals the fopen command, file open, which means, and that we need the file name, the one we need to read, and I could represent that with the R. And if you remember when we did that in the class, the R represent for me. So first I will identify things. FID means for me file identifier. And the R represent for me, I'm just making it easy for you, means open file for reading. So that is a command fopen. I always recommend you, if you forget about these, just please search in there and you can find whatever things you want to search in to find help for you. All right, what's next from that? After the file open, we want to actually try to find the location for them. So location again, we need to update the location. Here will be ifile, because the first location was just the same number of files, which we collected earlier. And that location ifile equals, what we're trying to find is to read from it. So we use the command text scan. As you can see, I put it there. And I will read the file ID identification, the FID, comma, and now we need to read the numbers. So remember the percentage and the S. And then we're reading the first column, but also we need to use the delimiter. We make sure we don't want to use that for the file name, so we use it for the respect to comma, and then that will read for me the file. So what does mean that? I would just put this U, the file contains a comma after the placement. So when we include that, it means you got this information from it. So I would just put this for you, not subsection, and the delimiter means what we trying to achieve here. The comma is not included, and we go through that for it. Now, the T's can read the data format for a text file or a string, so that's also something for us to be familiar with if I want to know what's exactly we're trying to achieve here. Now, after I finish the file identification, now I can close it, F close, and then F close to what's the FID. And then I go to find what's the next things from it is the warning level. So warning level is a new name we added, but it's relevant to the question itself. Equals, we're trying to read that from the file itself, DLM read, and that will be the file name. And in the file name, we use the equal, which is mean you must match the word warning level exactly equal to that. And that will read for you to create 1, 2, 1, and 1, and 4 ones, which we're trying to find for it. So what does mean that file name and that format here? It means we are looking for the row and column range for each one of these files for the warning levels for them. to get the right warning, because each file, it goes its own warning level. So if I try to open the river files, I'm opening here, you can see, for example, warning level is 6.1, and these are the data for it. So we're trying to read each one of these files warning levels. All right, so now after that, remember the mean, maximum, and minimum, they actually at the moment, at that level, they are not even reading for me the values. We just booked them to be zeros there, and that's why I need to be like concerned about them. So I will now calculate them correctly, but before that, I need to make sure I'm reading the water level as well. So water level equals DLM read, file name, and we will be reading exactly the 2 and 1. And now, based on the water level, I can calculate the mean underscore water level for the I file. Remember, we're doing it for I file because it's not for only one file, for the 5 files, equals to what we need to be equals the mean, and that for the water level. So that means we'll need to read that for the water level. Now I repeat that command or that equation to be maximum, and make sure to put here maximum. So, and then I repeat that one will be minimum, and this one will be minimum. Make sure to change for both, because that is just the name of the data will be stored in your workspace, but this one will go and search under the water level. So that's what we're trying to read for the water level files in them. After that, if the statement maximum, that's where water level for the I file, for any one of the files, bigger than the warning level, display, we should display a message to say the following message: the water level at, and I can give a space, and then here what we need actually is location for the I file, because we'll match that to the I file, and as well 1, because that's the file we go through it. And now we'll display for that exceeded the warning level, and then full stop, and we close that. That should be here to make sure like this is related to that comment. So if the maximum water level for any one of these 5 rivers data bigger than the warning level, which is read from the text file from the CSV files, then the display message will come here under the command window saying the water level at that, which is the name of the river, exceeded the warning level. Happy with that message, everything is fine. I need to end the if statement. So that is if and the end the statement, but also I need to end the for. So I'm ending that one of it. And you can see now how nicely this will give you the location for each one of these if statements. So that is for all 4 files. Now, after we end up with this, we need to find the results. So water results equals, the results we're trying to maintain here is the minimum underscore water level, and space mean water level, space, and then maximum underscore water level. So these are the results we're trying to display for the 5 rivers. And the way of how we want to display them, this time we use bar. That's the command for bar. And we put water results because will be displayed nicely in that way. But we want to label the Y label with the following to be represent water level. The units is in meters, so we assume the meters. And then the other things we will do here, it's a new method, it's called the excess handle GCA. So excess handle, I'm going to explain that very soon, equals GCA, which means that one is used to handle the excess for command to get the handle for the excesses for it, but required to set that value. So we set the value to be excess handle with the following command, x tick labels. You can see it is already there, but we need to make sure we can correct it. Tick label, not labels. X tick label, the L capital, we can put it there. And will be to bring what? We're trying to bring the location. But that location with respect to the different files we have. And then based on it, we can close that one. So that is mean the X tick label to replace the location of the files from 1 to 5 to match them with the river level data font. All right. Now, after we replace that, we could add the legend. Legend for us will be minimum, mean, and maximum. Now we save it. If there are some errors, we try to check and we see if there's something. Looks like everything fine. We run the file and sticks the run simulation, and we see that there are a few errors here, which we need to find. So warning level DLM read. So I think I misspelled the warning level DLM read for it. That one. So it's good. Picked up for me. So that it should be DLM read. Okay. So that is the message. Was wrong. Save again. Which is that the good things. When it's something wrong, always go through it. So there is, we get the results. Two information we got here. First, the water level at one of the rivers exceeded the warning levels, and that is the message we produce. Here is showing the 5 different rivers: Hamilton, Huntley, Narwahia, and showing the minimum in blue, the mean in orange, and yellowish. It's a maximum value for each one of the water level for each of these rivers for them. So that is a good way to understand how can we plot and calculate the maximum, mean and minimum values for the rivers, and as well to display a message which of these rivers exceeded the warning level based on the data. I hope you enjoyed, and please try to improve the script and make it even better, and any suggestions to improve the script, you're welcome to do. Thank you.